Greetings, my difficult divisors. We're going to talk about long division in this video. We're going to talk about long division because sometimes we want to divide two numbers and we can't do it evenly. Okay, so we need to come up with a way of dividing two numbers and expressing something that might be left over. Now, I'm going to do this in two different parts. So I'll go ahead and call this part one. If you already know the basics about division, you might want a refresher and watch this video. But in part two, I'll do slightly more complicated examples. But for those of you that are struggling with long division, it's probably complicated enough just doing the basics. So I want to start off very, very basic and say I want to divide 5 into 16. Okay, now 5 does not evenly go into 16. So we know that 5 times 3, well, that's 15. So it would go in there 3 times, but we'd have 1 left over. And that's essentially the point of long division is we want to divide large numbers. Sometimes they divide evenly, sometimes they don't. So long division is a way of dividing numbers where sometimes it does work evenly. I don't want to give you the impression that long division only works for things with uneven divisors. But the way that I would write this is 3 remainder 1. All right? And I don't know how you might express remainders. What this essentially says is 16 is the same thing as 5 times 3 plus 1. 5 goes into 16 3 times with 1 left over. All right? So that's how you might write it, like that. So the way that we do it in long division, and we'll get used to this notation, is with this division bracket thing. So the way that we're going to do it is a process. We're going to do it step by step, and this is the process that I will use in all of my examples. So I want to know how many times does 5 go into 1? So that first number there, 1. Now 5 doesn't go into 1 at all. Okay? So I would skip 1 and I would move on to the next set of 2 numbers. So all right, 5 does not go into 1, but does 5 go into 16? Yes, it does. It does so 3 times. All right? Now, what I'm going to do is ask how many times does 5 go into 16? That happens 3 times. And I'm going to multiply 5 and 3. So take whatever's up here and multiply it. 3 times 5 is 15. And then I will subtract these two numbers. 16 minus 15 is 1. And so this is one way of getting my answer. I'm done with my division. I've run out of numbers here. So 16 divided by 5 is 3 remainder 1. Now let's talk about a different way of representing this answer. How many times does 5 go into 16? Well, we already did that. 3 times 5 is 15. Subtract, I get 1. Now this 16 is really a 16.0. And so what I can do is I can drop a 0 down here. Okay, and we'll see a lot more examples of this in a bit. So I have this remainder of 1. I'm going to drop this 0 down. How many times does 15 go into 10? I can represent this as a decimal. 15 goes into 10 twice. And now I put this decimal above this decimal point right there. And so I get that 16 divided by 5 is 3.2. Or we could write this as 16 over 5 is 3.2. Okay? So there's a few different ways of representing our answer. Sometimes we want to represent that with remainders. Sometimes we want to do those with decimals. If I've already lost you, that's okay. We're going to do many of these examples. Again, I say it all the time. The only way to get good at math is to practice, practice, practice. Now, before I move on to something slightly more complicated, what I do want to do is point out a very common mistake that students might make here. Okay, so let's look at something that is wrong, and we'll see why it's wrong and how to fix and notice when it's wrong. So let's say I'm doing 5 into 16, and I ask how many times does 5 go into 1? 0 times, it doesn't. How many times does 5 go into 16? Now we know that the answer is 3. But what if I'm lazy and I go, it's 2, because 2 times 5 is 10. Okay? If I do 2 times 5, I get 10. And when I subtract these two numbers, 16 minus 10 is 6. So this is one way of knowing that you're not on the right track. Okay, this number here, this 6, has a 5 inside of it still. So 2 wasn't big enough. There's still a group of 5 that I can pull out of there. Okay, 5 goes into 16. So then you might say, ooh, this remaining value down here, that was bigger than 5. That should send off alarms in your head saying, uh-oh, I can actually make this number bigger. It's not 2. 5 goes into 16 3 times. 3 times 5 is 15. And now when I subtract these, I get 1. When we do the subtraction here, this number should always be smaller than that number here. This happens to be called your divisor. All right? So 5 does not go into 1, and so we can write that as remainder 1, or we could write that as a decimal, however we want to write the answers. Okay? So again, this is important. Now let's say that you went too far, and you said, all right, 5 goes into 16, let's try 4 times. Okay, that's way too big. Here's how you know you're way too big. I'm going to do, again, this multiplication. 4 times 5 is 20. And if I subtract these, I get a negative number. 16 minus 20, I cannot take 20 away from 16. I mean, I can. I get negative 4, if you know about negative numbers, but this cannot be negative down here. This number that I get after I do my subtraction has to be less than what I'm dividing into. Okay? Has to be less than my divisor. So, with that said, let's start a slightly more complicated example. Let's do 613 divided by 5. All right? So, 5 goes into 613. So, I start here. I ask, how many times does 5 go into 6? It goes into 6 one time. Now that I've established that, I do my multiplication. 1 times 5 is 5. And I subtract in this column right here. 6 minus 5 is 1. Now I have some stuff left over right here. And so as long as you still have stuff left over here, you bring down this 1. Okay, we'll leave this 3 alone real quick. By the way, I knew that I was right because I got a 1 right there, and 1 is less than 5. So I know that I'm on the right track. Now I bring this 1 down. How many times does 5 go into 11? 5 goes into 11 twice, because 2 times 5 is 10. And I just keep repeating that process. 2 times 5 is 10. I multiply here. And now I subtract that. 11 minus 10 is 1. I still have numbers over here, so I'll bring this 3 down. How many times does 5 go into 13? Well, 3 is too big because we've done it a few times up here. 5 times 3 is 15. 15 is bigger than 13. So this is again 2. Because 2 times 5 is 10. When I subtract these, I get 3. And this 3, after I do my subtraction, is less than 5. And it's positive. So I know that I'm on the right track. Now, I've just run out of numbers to bring down. So at this point, I could write my answer as 613 divided by 5 equals 122 remainder 3. In other words, 5 goes into 613 122 times, and then I have to add an extra 3 to get into 16, or to 613. There we go. Now we can also write this as a decimal if we wanted to, because after this 613 there's a 0 here, a 0.0. So instead of writing it as a remainder, I could bring down this 0. How many times does 5 go into 30? 5 actually goes into 36 times evenly. 6 times 5 is 30. Subtract these two values and I get 0. And actually I'm done, because there's another 0 here that if I bring it down, how many times does 5 go into 0? 0. 0, 0, 0. Zeros everywhere. So I can also write 613 divided by 5 as 122.6. Or I could write it as 613 divided by 5 equals 122.6. If only there was a way to check our answers. There's always a way to check your answer in math. Division is undoing multiplication, so to check, let's actually multiply to see what we get. All right, So let's check the decimal answer. So 122.6. Let's multiply that by 5. And let's cross our fingers and hope that we get 613. 6 times 5 is 30. So 0, carry the 3. 5 times 2 is 10. Plus 3 is 13. So I put a 3 there, carry the 1. 5 times 2 is 10. Plus 1 is 11. Carry the 1. 5 times 1 is 5. Plus 1 is 6. And this had 1 decimal point in it, so I move this over 1 decimal point. And look at that. I get 613. So if you need to write your answers as decimals, then this is how you would do it right here. Okay? You would check your answer by taking that decimal, multiplying it by 5. We get 613. We're done. Here's another way to check your work. Let's take 5 and multiply it by 122. 5 times 2 is 10, so I put a 0 here, carry the 1. 5 times 2 is 10, add this 1 up here, I get 11, carry the 1. 5 plus 1, or 5 times 1 is 5, plus 1 is 6. Uh-oh, it didn't get 613. But that's okay, because that's what that remainder was. So 122 times 5 plus this 3, this leftover 3 that I had, equals 613. So 613 does equal 122 times 5 plus that remainder of 3. So that worked out as well. Right? You can always check your work. Now there's one final thing that I want to say before we move on, and that is, what if you wanted to represent your answer as a fraction? That's actually pretty easy, so I left that for the end. The way that we do that is we take our remainder, so where was it? That was 122 remainder 3. And the way that we write that is a fraction, where we could say, so another answer, (613) divided by 5 is 122, and then plus the remainder 3 over 5, or 122 and 3/5. All right, that's the non-plus way of writing that as our answer. So multiple different ways to write your answer, to express your answer, but they're all getting at the same value. They're all getting at how many times does 5 go into 613, and then is there anything left over? And again, this remainder should never, ever, ever exceed your divisor 5, or whatever the divisor happens to be in your problem. You know what? That was so much fun. I think I'll do it again. How many times does 4 go into 986? Well, let's just do the wrong thing. All right? Maybe you look at 4, how many times does that go into 9? Let's do it one time. Do our multiplication. 1 times 4 is 4. I subtract 9 minus 4 is 5. If you did this, you should see the mistake. This remainder of 5 is too big because my divisor is 4. So this can't possibly start with a 1 out in front. So, and that's fine if you make that mistake, especially as we do more complicated examples. That just tends to happen sometimes as you're feeling your way through the problem and trying to figure out what the answer is going to be. But 4 goes into 9 twice because 2 times 4 is 8. And if I subtract these, 9 minus 8 is 1. I bring down this 8. And I repeat that process. How many times does 4 go into 18? 4 times. 4 times 4 is 16. And I subtract and I get 2. How many times does... Oh, forgot to bring down my 6. All right. How many times does 4 go into 26? All right. That happens 6 times. Because 6 times 4 is 24. And when I subtract, 26 minus 24 is 2. Okay? So, here's one way of writing our answer. We could write it as 246 remainder 2. I've run out of numbers to drop. Excuse me. I've run out of whole numbers to drop. And so that's how I know that I'm done. And you can check. 246 times 4 should give you 984. and you get the next 2 because you have that remainder right there. If you wanted to write it as a fraction, you would write 246 and then 2, which is my remainder, over 4, which was what I was using as my bottom number, my divisor. And 2 over 4, that's a fraction that can be simplified. So I have a video on how to simplify fractions. This is 246 and 1/2. 2/4 is the same thing as 1/2. Make sure you always reduce your fractions. Link to the simplifying fractions video will be in the comments of this video. And then finally, if you wanted to represent this as a decimal, I'll just continue this process. Bring down the 0. How many times does 4 go into 20? That happens 5 times. 5 times 4 is 20. Subtract these, I get 0. No more remainders. And hey, look at that. 1/2 we know is a 0.5. So these answers do in fact match. You can write this as 246.5 as a decimal if you like. All right, let's do another one. How many times does 6 go into 394? Well, let's do it. How many times does 6 go into 3? It doesn't. How many times does 6 go into 39? Well, 6 times 5 is 30, but there's still a little bit more you can go because 6 times 6 is 36. So I'll put that, and I'm putting it above the 9 here because 6 didn't go into 3, so I'm not going to put anything above the 3. 6 does go into 39 6 times, and so I'm going to put that 6 above the 39. 6 times 6 is 36. Subtract, and 39 minus 36 is 3. Bring down the 4. 6 goes into 34, not 6 times, because that's 36. That's too big. And so that's going to be 5 times. 5 times 6 is 30. Subtract, and I get 4. So one way that I could write my answer is 394 divided by 6 equals 65, remainder 4. We can also write this as 394 divided by 6 is 65 and 4 over 6. But there's a common factor of 2. 4/6 is the same thing as 2/3. Again, simplifying fractions video in the comments down below if you need to refresh on how I go from 4 over 6 to 2 over 3. And if you like decimals, and I think we all do, go ahead and put a 0 at the end there. Bring that down. 6 goes into 40 6 times. 6 times 6 is 36. Subtract. 40 minus 36 is 4. Now wait a minute. The other examples that we've done stopped at this point. This one didn't stop. That had a 4 there. And so, you know what? There's actually another 0 here because 394 is 0.00000. There's just zeros in that decimal representation afterwards. And so I can bring down that 0. And that looks familiar because I'm asking how many times does 6 go into 40? 6 goes into 40 6 times. 6 times 6 is 36. Subtract. 40 minus 36 is 4. You know what? There's another 0 there, so I bring it down. And I'm actually going to repeat this process. Hopefully you can see that I'm never going to stop getting 4s down here when I subtract. And then I bring down the next 0 and I get 40. 6 goes into 46 times. I'm going to repeat this process over and over and over again. And so if you've seen this in math, when you have repeating decimals, you could write that as 65.6 repeating. Okay? The little bar over this number indicates that this 6 is going to go on forever. There's going to be a 0.66666 all the way down the line. It will never stop. Okay? So we have our remainder version of the answer. We have our mixed fraction version, and then we have our decimal representation. And in this case, this decimal never, ever, ever ends. It's just going to be a string of 6s all the way to infinity. Okay, and now one final example. I'm going to keep the divisor as a single digit, 8. I'm going to do 9,687. Okay? Because, I mean, I can just keep writing numbers here. Once you understand the process, some people call that an algorithm. Once you get this, you can just do this forever. I just got so excited I dropped my pen. Okay, how many times does 8 go into 9? All right, that actually goes into 9 once. Because 1 times 8 is 8. Subtract, I get 1. Keep repeating this process. Drop the next digit. Now 8 does happen to go into 16 evenly. Happens twice. It doesn't mean I'm done because I still have digits over here to drop. 2 times 8 is 16. Subtract, and I get 0. Bring down the next number. 8. Now forget about that 0 there because that's really just 8. How many times does 8 go into 8? Ooh, once. Evenly once again. Because 1 times 8 is 8, and I subtract those numbers. 8 minus 8 is 0. And then I bring down that 7. Now I'm sort of breaking my own rule. If you've ever had me in a class, you know that I shouldn't be mushing all this together. I should always give myself plenty of space and plenty of room. How many times does 8 go into 7? It doesn't. 0 times. Remainder 7. So I have 7 left over, which is totally fine because 7 is less than 8. Your remainder is always smaller than your divisor. And so I would write my answer as 1,210 remainder 7. That would be the remainder version of my answer. I could also write it as 1,210 7 over 8 if I so chose. If I so choose, if I so chose. Those words have lost all meaning to me. Or, if you want a decimal representation, I did jump the gun a little bit because I didn't really finish out my process because I knew 7 was going to be the remainder, but 0 times 8 is 0, and I subtract, and then I get the remainder of 7. Okay? Now, if I wanted a decimal representation, now I put that 0.0 at the end here, bring down that 0. How many times does 8 go into 70? All right, so that's going to be 8 times. Because 8 times 8 is 64. And look at me running out of room all over the place. All right, that's going to be 64. 70 minus 64 is 6. Now there's another 0 here that I can keep borrowing from until I figure out the pattern or until I start getting remainders of 0. So I'm going to drop down that 0. How many times does 8 go into 60? All right, well, 8 times 8 is 64. That's 4 too big, so it's going to be a 7 right there. 8 times 7 is 56. Subtract these, and I get 4. Now, these haven't really repeated yet. I got a 7, I got a 6, I got a 4. There's another 0 that I can borrow from in this decimal representation of my number. And now I'm done because 8 goes into 40 5 times evenly. 5 times 8 is 40. Subtract these, and now I just get a bunch of zeros for my remainders. So as a decimal, you could also write this as 1,210.875. Now in this case, it was not a repeating decimal. It stopped after 3 digits. Okay. This previous problem, these 6's kept going forever. That's what that bar indicates. But this right here, after we did this decimal 3 times, then it did stop. We got remainders of 0, so we knew that we were done. And if you know anything about fractions, 7 over 8 is 0.875. So that agrees with what we learned way back when we were converting fractions to decimals, decimals to fractions. Now, it wouldn't be a true Max's Math Magic video unless I left you with some practice problems. So these are 4 problems for you to try. I'm going to go ahead and put answers in the comment section below so you can check your work. But make sure you go through these problems, at least these problems, and make sure you know how to do it. If you try any other problems, make sure to check your work. Don't forget to like this video. Don't forget to subscribe to this channel because math videos are coming at you from all levels and all directions all the time. I'm doing basic math, I'm doing calculus, I'm doing algebra, I'll be doing trigonometry, I'll be doing all sorts of linear algebra and differential equations. So as I have time, I will make more of these videos. So I will be here with you through your mathematical journey from now until you're done with math, which is hopefully never. So don't forget to like, don't forget to subscribe. Thanks for hanging out with me. I'll see you next time.